So today we are going to talk about homogeneous differential equation. Homogeneous differential equation, and a differential equation of the form dy by dx. Differential equation of the form dy by dx equals to f of xy and phi of xy is called to be an homogeneous function where each term of fxy and phi xy have the same degree. Here both fxy and phi xy have same degree, then only we can say that it is a homogeneous differential equation. Let's see how fxy and phi xy have same degree. Means let's take an example. Let fxy, where f is a function of xy, where we can, let's take it as 3x square plus 5xy. Okay, and then if we take phi xy, which is also a function of x and y, let's take it as xy. Then dy by dx equals to 3x square plus 5xy by xy. We can clearly see that the upper part have power x to the power 2, and here x have power 1 and y have power 1. So the total power of the upper side function fxy is 2. It have power 2 or degree 2, and the downside function have also power 2. Okay, if both the upper side function and lower side function have same power, then we can say that it is a homogeneous differential equation. If one of them have different power, or we can say that if dy by dx equals to 3x square plus 5xy by x cube, then the upper side have power 2 and the lower side function have power 3. So it is not a homogeneous differential equation. It is a non-homogeneous differential equation, and the solution is a little bit different. Okay, so we are going to talk about only the homogeneous differential equation solution. Okay, to solve this type of equation we have to take some substitution, and the substitution is like y equals to vx or x equals to vy, which depends upon the situation. What type of equation is there, that depends if we take y equals to vx or x equals to vy. So let's take an example and see how it works. Okay, then q. Okay, question is dy by dx equals to 3xy plus y square by 3x square. Okay, so here we can you can see that this is a homogeneous differential equation, as the power is here 2, upper side function have power 2 and lower side function have also power 2, and this forms an homogeneous differential equation. And if we try to solve it by other method, like previously we see that in separation of variable, here we can do this because it is a function of both x and y. The upper side function is both a function of x and y, so we can't separate it. That's why we have to do a little bit different from the previous solution, which we already studied in separation of variable method, to get the solution of the differential equation. So let's see how. If we take substitution, let y equals to vx. Okay, then dy by dx equals to v plus x dv by dx. We simply differentiate both sides, and if we put the value of dy by dx here, then what we will get? We will get v plus x dv by dx equals to 3. Put the value of y here, so we get 3v x square plus v square x square by 3x square. Okay, so we can write it as v plus x dv by dx equals to 3v plus v square by 3. Okay, so then we can solve it as we can further solve it like v plus x dv by dx equals to 3v plus v square by 3. Okay, then x dv by dx equals to 3v plus v square by 3 minus minus v, so we can write it directly minus 3v, and here it cancel out, and then x by x dv by dx equals to v square by 3. We can simply write it as 3 dv by v square equals to dx by x. Now we have to integrate both sides. Then what we will get here, 3 integration of 1 by v square equals to minus 1 by v equals to ln x, and let take a constant ln c. Then what we will get 3 the v value is v equals to nothing but that y by x, so we can put it as minus 1 by y by x ln xc, and it becomes 3 minus 3 x by y equals to ln xc. Okay, this is the solution. This is the solution of the homogeneous differential equation. Okay, so that's how we can do this. And if there is any boundary condition is given, that initial condition if given, then we can still solve it. Now take another example. We can see that here the differential equation have power 1 in the upper side, and but there is a constant term is there. Other than the constant, the all term have power 1, and the lower side function have also power 1, but there is also a constant is there. So this is not an exact homogeneous differential equation, but we can still solve it by reducing it into a homogeneous differential equation. So let's see how we can do this. Let us take x here the x equals to x plus h, and y equals to y plus k, capital Y plus k. So if we take dx, then it becomes capital derivative of capital X, and where h and k are arbitrary constant, and dy equals to dy, then dy by dx equals to d capital Y by d capital X. So we can substitute the value of small x and small y in this equation. Okay, let's substitute the value of small x and small y in this equation. Then we will get dy by dx, and this equals to putting the value of small x here, then we get x plus h plus 2 capital Y plus 2k minus 3, and then 2 capital X plus 2h plus y plus k minus 3. Now rearrange this a little bit, then we will get dy by dx x plus 2y plus h plus 2k minus 3, and 2x plus y plus 2h plus k minus 3, where h and k are arbitrary constant. We choose the constant value in such a way that this term wholly vanishes. So let h plus 2k minus 3 equals to 0, and 2h plus k minus 3, this term also goes to 0. Okay, so if we take it, then what we will get now, if we multiply 2 with this equation, then this equation becomes 4h plus 2k minus 6 equals to 0. And now subtract this equation from this, then we will get h plus 2k minus 3 equals to 0, and subtract it, then it becomes like 3h minus 3 equals to 0, then h equals to 1. And if we put the value of h here, then 1 plus 2k minus 3 equals to 0, then 1 plus 2k minus 3 equals to 0, then 2k equals to 2, and then k equals to 1. So we take the constant value h equals to 1 and k equals to 1, so that now the equation becomes dy by dx equals to x plus 2y by 2x plus y, and the constant term goes to 0. Now this equation is a homogeneous differential equation. So now we can solve it like y equals to vx and dy by dx equals to v plus x dv by dx. And now put this here, put the value of dy by dx here, so we get v plus x dv by dx equals to, here we can put it as 1 plus 2v by 2 plus v, as the x term are cancelled out. Then the equation becomes x dv by dx equals to 1 plus 2v by 2 plus v minus v. So minus v, then it becomes 1 plus 2v minus 2v minus v square by 2 plus v x dv by dx. So minus 2v cancel out, then we can simply write it as x dv by dx equals to 1 minus v square by 2v. Okay, then now we can solve it as 2v by 1 minus v square dv equals to dx by x. Now integrate both sides. Okay, before going to integrate, we can also simplify the term 2v by 1 minus v square, as we can write it as 1 by 2 1 by 1 plus v plus 3 by 2 1 by 1 minus v. We can separate 1 minus v square into 1 plus v and 1 minus v, and give some constant, so that upper value becomes 2v. Okay, then this term dv whole integration equals to dx by x integration. Okay, then it becomes half ln 1 plus v plus 3 by 2 minus ln v equals to ln x ln c. Okay, then ln 1 plus v, and here if we take common out half, then it becomes ln 1 plus v minus 3 ln v. Sorry, here it is 1 minus v. Okay, then it ln xc. Okay, then it becomes ln 1 plus v by 1 minus v cube equals to ln, and here half goes to this side and multiply s2 ln x, and then it becomes ln 2 ln x c. And if we take out ln both sides, then it becomes 1 plus b by 1 minus b cube equals to x square c square. Here x is capital X. Okay, then if we put the value of y, what is the value of y? What is the value of v? V equals to y by x. So 1 plus y by x, and here 1 minus y by x whole cube equals to x square c square. So simplify a little bit, and it becomes x plus y by x divided by, means here x minus y whole cube by x cube. So we can write it as x cube by x minus y whole cube equals to x square c square. Then it cancel out x square, and the x square and this term cancel out. Okay, so now x plus y equals to x minus y cube into c square. So putting the value of x, what is the value of x? As we can see that we already write it as x equals to we write it as small x equals to x plus h, then capital X equals to x minus h. Similarly, capital Y equals to y minus small y minus k. Okay, so putting the value, and as we know h and k are 1, so it becomes capital X equals to x minus 1 plus y minus 1, and it becomes x minus 1 minus y minus 1 whole cube c square. Okay, then if we do it, x plus y minus 2 equals to x minus y minus 2 cube c square. Okay, this is the solution of the differential equation. So we can see that in this lecture we can see that what is homogeneous differential equation and how we can solve it by taking suitable substitution. And if the differential equation is not in a homogeneous function, then how we can convert it into a homogeneous differential equation and then solve it. And next we can see that linear differential equation, and then we see exact differential equation, and then we proceed for higher order differential equation, then we go for the power series solution. Okay.